So we're going to talk about what's new and useful. So I'm going to just highlight some new features or some updates to existing features that you may have missed. I will talk. I saw on the Discord that caching and performance is sort of hot topic with data. So I'm going to spend a bit of time talking about it, and feel free to ask additional questions at that time. And then we just go to general Q&A where everything goes. You can ask any questions, everything you ever wanted to know about data, or you're working on a specific project and you want some advice, anything goes at that point. So a bit about me, as Grace has already introduced me, I'm technical product manager at Wix Code. My name is pronounced Giedrius Graz. It's a very Lithuanian name, as I'm from Wix's Vilnius office. I've been a team lead and product manager in Wix Data from 2017 till 2022. Now more generally in Wix Code. I also work on some other both data and value related projects. Also, as a hobby, I work at Vilnius University. I lecture there about non-relational databases, and Wix Data is one of them. So a few feature highlights that you may have missed, hopefully not, but to remind you. So the first one is the monitoring dashboard. It exists for quite a while, but it used to be Velo only, so you were only able to monitor your functions and how they perform. We've later on added data, and we have updated this board more recently, so it's kind of a good tool to check on occasionally and see if your site is doing okay. So if you have multiple sites and you kind of want to quick glance how things are performing, this is kind of a good built-in tool for that. Of course, you can, always in Velo, you can go and explore logs, see what's there, kind of drill into details, but we have this dashboard that warns you if something is not okay. Like here you can see I have this red or bubble here saying, okay, there's something wrong. That means there's a higher error rate. I think it's 10 or more. I think there's probably something wrong with the database and it deserves an attention. So, we'll show the errors, we'll show the request, bottom, it's not see it, will show, it does show request duration. So if your requests are slow, you can say, okay, why are they slow? Maybe I have to do something. So sort of general overview that's useful to know. Second feature that you may have missed, new backups are now taken in a way that we can restore collection by collection. I know this was a common user request that I want to restore something and not the others. I made a mistake in some data, but the other data is correct. So we now allow disaster recovery by collection. Now, this is only applicable to newer backups. If you have old manual backups, especially from months back, this will not work. In that case, it will restore full backup and it will warn you. So if you're restoring a backup and you get kind of a warning box, then it means it will do a full restore. If you're clicking restore and you're getting this box, that means this is a recent enough backup that it will actually go and allow you to restore specific collections. If there are references, it will try to warn you and so if you remember before, or sort of the usual mechanism was that if you update a collection, the collection changes go live, go live to the content manager, go live to the site once you click the site publish. And the recent change is that now the collection changes are immediate. So whatever you do in content manager is going to be immediately visible in the content manager that's open from the business manager. And those changes will immediately affect your site access or external access. So this is kind of one schema, one collection view globally for your site. So that separation between the editor schema and sort of business manager live site schema has vanished. So this eventually will mean that you can update collection from anywhere, from business manager, from APIs, from not just from editor. And this is sort of the first step that we're taking to unify that experience. It's also a bit more in line how all of Wix works, because all the changes and all the other products are usually immediate. And in Wix Data, it was kind of that you had to publish, and it was occasionally confusing. Good. Now, a section where I try to answer some of the questions more generally. And again, if you have any question, feel free to hop in on the call and just ask them the way. Good. So caching at Wix. So I want to start by talking about how generally Wix data flow happens, so that we can talk more about how the flow and the caching works. So let's say this is the client. This is the client. This is someone on their mobile, someone on their desktop visiting a page. Now, where does that request go? The first request to get the page will go immediately to what we call micro point of presence. And then if needed, we'll continue to our main data center. A main data center is where everything lives. It's where the databases are, it's where the main Wix services are doing the business logic. It's main data centers usually have smaller data center that's next to it, not directly part of it, that runs your Velo code. So these are big. There are a few of them. They're all in safe, both data safe and legally safe locations in European Union, United States. Very safe. There's a few of them. Now, whenever your request goes to the main data center, it also passes what we call micro point of presence. Gateway into Wix Data Center. You're going here for the public internet. It's your ISP connection. It's whatever your ISP has connected to any other global backbone providers. And this is typically a connection that's shared by many ISPs, by many users. This is what we call the public internet. So we have these points of presences to make sure they're closer to you and your clients and your visitors, so that you can hop on through them and then hop on the private internet. This is connections that we rent out from other providers. This is connections that we buy. This is let's call it a higher quality internet, because it's not publicly shared by anyone and not anyone can get on it. We reserve some capacity just for Wix traffic. So it's high quality, low latency connection to our main data center. So we try to capture your traffic as fast as possible, as close as possible to a user, so that it can quickly get into our data center with least amount of disruptions. Because the longer this chain is, the more routers in the front end, the longer the requests and the packets have to travel, the more chances that something will happen. There's going to be contention, diversion, packet loss, and whatnot. And another place where static resources go. So these are dynamic, because this is get me the page. This is API call, give me product information. This is Wix data call, query the query. This goes from micro point of presence into main data center, which is closest to us. So you'll pick first the closest micro point of presence, then every micro point of presence will have some data center that's assigned to it. Now, while data centers are a few, this is 10 plus. CDNs, there are a lot. That is probably close to 100 locations where the content delivery network exists. This is your JavaScript that you wrote in Velo. This is the Wix JavaScript. This is your images in media, your videos. Everything that's static and doesn't change gets cached and gets put close to your users. So it's likely, in the country or even the state close to your users. The network is really wide, really rich, and we work with multiple service providers, multiple CDNs to kind of coordinate with them and give you the best CDN there's possible to offer in the world. So now I'm talking about this architecture because there was question about caching. Now, where does caching live? Obviously, in the main data center, there's little sense to cache something here because, data is here locally. So these micro points of presences also contain cache, so we can put some of the data closer to your users. And the CDN is, of course, cache as well. So if in some location we don't have something gets request, we know that some site lives in that location. It's resources that are being requested that are going to be cached in CDN for a long time. Now, this cache is a bit more special. It caches pages. You probably know that pages at Wix get rendered occasionally twice. So if you ever wrote public code that, for example, counts visits, and you said, let's insert +1 into database, or let's insert a visit in database, or let's run some other code that has side effects, then you might have noticed that your code runs twice, or your registers visits twice. And often the question is for those newer to this is, why did my code run twice? I just went once to the page, but I see my front-end code being invoked twice. And the reason for that is that we also render that page in the backend, as what we call in the server-side rendering. So we have a big data center here that sort of pretends to be a browser-like thing, and we execute all your front-end code. We generate the HTML for the browser, and we ship all that package to the client so it can render it faster. It's very simple, it's very minimal HTML that's just can be rendered quickly on mobile on the client. There's no huge dynamic JavaScript that gets to be executed to make everything run. So it renders quickly, but your buttons still don't work, and then the client side kicks in, makes everything work, adds the interactivity to the site. But the first rendering is very fast. Now that first rendering can also get cached. So if I render that page and that page is cacheable, I'm going to cover what's cacheable slightly later. It's going to stay here as well. Like the copy of it is going to stay here. And if a second user goes to the same page, it may not even go to main data center for getting rendering and gathering all the data. It's just going to take this copy of the page and quickly return to the client. So this makes it a lot faster. Now, what also happens here is that cache, together with itself, may pack in some resources and some data that the page needs. So, for example, if you go to a product page, it may also pack all the product information needed to render that page even on the client. So once the client code kicks in, once your API kicks in and says, get me the current product that's being displayed by this page, it's not going to do an extra call here. It may just take that page and return it from this cache, like the data is together, fetched from the first request. So you're saving on that call. And the reason why I'm covering this in data presentation is that data does this too. Now, the cache can be for pages and can be for APIs. Very few APIs are cacheable now. We're working on sort of making more API calls cacheable. Wix Data is not cacheable, so whenever you do API call in your front and say Wix Data query something, you are going through this pipeline to fetch data to one of the main data centers. But when you're on the dynamic page, and dynamic data set needs to fetch data, if the page is cacheable, if it's eligible for caching, that server-side rendering stage is going to take that data set needs, is going to package it with that HTML initial rendering, and it's going to cache it here. So once you get that dynamic page, once your client gets that dynamic page from the cache, it will also get the data. So it's going to be much faster. Like it's going to both the static, the first sort of render of the page is going to be faster, but also making it dynamic, or making all the buttons and everything work, and running your code is going to be faster because it already has the data. So dynamic pages and their calls are cacheable, to answer someone's question in Discord, but the data calls itself are not yet cacheable. Some Wix APIs are, but Wix Data specifically is not. So a bit more about cache. So the cache duration, like default cache duration, is now 7 days. So whatever gets in this cache is there for 7 days. CDN cache is very long-lived. So if someone accessed your site in Germany, CDN site for Germany is going to have it for a long time. data, but however, data changes invalidate cache. So if you go and update something on the page, there's an event saying to the cache services. So basically, main data center says, "Hey, data changed. All the caches you may want to check and invalidate that date." So there's two ways the invalidations happen. Some applications will invalidate everything. So for example, your publishing in the editor invalidates all the cache. Whether it was data pages, stores pages, API cache. If you, hey Tomer, see if you change something, it's going to invalidate all cache for the pages. We're slowly moving towards the process where invalidations are granular. So we're going to invalidate only what changed. So for example, in data, if you're going to update one item, it's going to try to be smart and say, okay, I need to invalidate only the pages and other resources that are affected by that data item, but not anything else. So we're moving towards more granular invalidations. But full invalidations can still happen. You can also force it via an API. So if you made some changes that don't require publish, if there were some from external API or anything that got cached, or you can in fact go use this side backend package and call invalidation. Another thing to know that sites that have front-end code that runs already, so tries to actively put content on the page, are not by default cacheable, and so you have to go to page settings and say, I'm going to control this manually and force caching on that page, if you know that's necessary. Good. So what's cacheable? Again, I think I've already mentioned server-side rendered HTML pages. So once you're running it from the code, the filters tend to be very dynamic. So there's a lot of variability, like the same query doesn't repeat that much. So it's hard to know how to cache it smartly so that it's actually useful. Yeah, but application data on the page, many applications can make use of it, and your application widgets, data, your dynamic page items, they do get cached together. Now, another thing to know about caching is if you do enforce caching and something gets cached, the side effect that sometimes you may notice and not everyone knows is that once we render a cached version, if it's different from what would client render, for example, you force the cache on the page and you fetch something from external API, or you did something, I don't know, show current time, cached version will have one values. So let's say, last cached version was a day ago, so it may show a current date that's 1 day ago. If it got cached on 3rd of May, you may show 3rd of May. But once the client side kicks in, once after the initial render, like with the page hydrates, your code would then run on the client and would set a different date. So if you're doing this with a lot of items like setting labels, setting images, setting something on values that change a lot, caching may be slightly detrimental because it will include this flicker of rendering one thing and then quickly re-rendering from the client on the other thing. So you should always be mindful, like, do my data sources change a lot? And if so, maybe caching is for that page is not the right answer. Good. Any questions about caching or Wix infrastructure? Good. So another thing that you asked on Discord, and it's usually a common question, is how to make things faster. So again, few simple tips, a few simple techniques that you can employ. So one is what's slow is data. It's both, your data is in database somewhere. It's probably sitting on disk. So the more data you have, obviously, the more times it takes to read it. So one trick you can avoid in sort of like really large databases and in situations where you don't need all of it is you can choose to say, I'm going to split my data into a smaller collection, larger collection. You can join them by reference. You can just have data with full collection and data with less, and just when possible, query the smaller one. So one good example, let's say you have a news page. Like news articles are sometimes big, and their feature pieces can feature a very long story, so that textual content is like tens or hundreds of kilobytes. But on the front page, in the news page, you typically show what, maybe a image or just a headline or maybe the author. So that's much less data than the full article. So what you can do, instead of querying the collection version with the full article, you can query the version that doesn't have that full body, only has the data that you want to show in other places. And that would make the query itself much faster, as well as transferring less data over the wire. So it's less data from disk and less data over the network, thus making it faster. Obviously, the downside is that you have to maintain it between two collections. So one easy trick is you can say, your users would use Content Manager to write the full article and full page, but there would be another collection that you would populate via hooks, where you would put only the details that you commonly need. New feature to Wix Data API, if you haven't noticed, it appeared. I don't really remember when, but it's not that old. So you can say only fetch specific fields. So you can also, if you have these very large fields, you can avoid transferring them over the network. So this is, travels faster over our networks, and it's also faster over the user network, as the client is mobile user in some remote areas, so you can save quite a lot of his bandwidth and also make site load faster. Another obvious thing is use indexes. Indexes are there for quite a while, and if you have a large collection, again, what matters usually is data size and how much data from the full collection you need. If you're querying data by some common attributes, for example, you have like some pages where you cover by some that you query data for a single item by some slug or whatnot, by all means use indexes, because they speed up the lookup. In general, if you run a filter against the database, it's going to scan all items and try to find all of them that match that filter. So if you have a collection with 10,000 items, even if only one matches the filter, it's going to read the full collection to figure out, how many there actually are and which one to take and send it to you. So every time with every query, more or less reading the full collection. Now, if you have an indexes like in the book, you go and you quickly find what you need by looking at just those values you're filtering by. And then going and reading only that specific item. So that's especially useful if items are large, but the fields you're filtering by are small. So you can go into a small index, find what you need, and only read those items that match the filter. Same as for ordering. If your query uses some ordering key, which is not default, the default one is index, it's going to be fast. But if it uses non-default ordering, or it combines filters with default or non-default ordering, now I need to read all the collection. Now I need to sort everything in the database memory to figure out which are the results that match the query and also are first, 50 or 100 by that I need to show, and only then I can start returning. So I have to read all database, I have to keep all items in memory, and I have to sort them. If you have ever had a really large database and tried using non-default sorting keys, you may even see the Wix Data fail and saying the data result is too large to sort. So it means it didn't fit in database memory, which is roughly 100 megabytes. So the page to sort and fetch is larger than 100 megabytes. We may not even be able to complete that operation, in which case you do need an index. because indexes are ordered, as you know, if it's a string alphabetically, if it's a number, you know, from 1 to 10, 100, thousands, and whatnot, and then we can quickly figure out which slice of that index, which items we need, and we quickly can give it to you. So when working with larger databases, you know, do get acquainted with indexing. We have some good materials explaining when to do what filters and what orderings are covered by what indexes, and we can, and it will guide you onto the right path. Another thing is not counting when it doesn't matter. So if you explore Wix data result, you know, obviously you've seen the items are being returned, but another field that gets returned by every query is the total count, like how many items there are fetching your query. So if you have 1 million items and you write a filter that matches 100,000, even if you're requesting for 50, there's this count query that is just running, scanning all of your collection, figuring out how many items in total there are matching your collection, and only then returning the result. So if you have a large collection, just the fact that you're counting adds to the duration of the query and makes it slower. If you don't need the count, and this is what we notice, not everyone needs the count. So for example, if you're not showing page numbers, if you're not showing user total count, you don't really care what's the number of the matching queries. So if you're using lazy loading, or you have a load more button, which just loads the next page and loads more, you don't really necessarily need to know. And in which case, in these cases, you can pass on total count property, which will omit the counting phase. So it will find as many items as you request up to the limit. And once it's full, it will stop scanning the collection. It will not do the counting phase, and will just return those items. And on large collections, this is a huge saver. It's especially notable when you're showing a table, for example, without the filter of all items. So if you have a lot of items, you have 10,000, but you're showing first 50, that counting stage, we're still counting all of your collection. It's still always there. So if you don't care, passing on total count flag will avoid that. And if you just need to load more, your result has next indication will actually tell you if there are more results or not. So this will make for more efficient loops. If you're scanning all data, there's like while has next, fetch next page, and process and do something with the full collection. Or if just showing some items where you have lazy or loading in order without paging, it's on large collections, it's quite a performance improvement. Now it's still a preview, it's still not in documentation. I'm mentioning it because it's going to be soon there, but I'm going to tell you a little secret, it already works. Another pro tip for performance is using hooks strategically. Hooks add to the query latency. So the fact that you have to run some code in a container, so that means before we execute query, if you have the before query hook or after, we have to call Velo, like data service calls, database calls. Velo says, execute that hook for that query, execute that hook for those items, then gets the results and only then passes to you. Now this adds extra overhead because we have to call this at smaller data center next to the main Wix data center. So there's a bit of overhead there. Your code also takes longer than 0, right? So it all adds up into making the query slower. But what you can do, what few tricks that you can do is try to use them more strategically. Like if you're adding calculated fields, instead of adding it in after query hook or after get, post item processing, you can do them on inserts and updates. So you add those calculated fields once, they're always there. So you're adding hooks and making a less common operation, a write and insert or update slower, as opposed to making the common read slower. Not always possible, but if it's possible, it's also a significant performance saver. Another trick that you can use, you can actually, if you're not using data binding and you're not using data hooks to transform data that's used in data binding, you can just use web method. So if you call web method from your front end, you call web method, and in web method, you call Wix Data, and then you take the result, you transform it there, and then you send it back to the front. Is going to be a little faster than running a hook. It's also a very good thing where the hook logic doesn't apply universally, and you want running it in some cases and not in the others. Like you don't want it in content manager, but you want it in live sites. So with methods is maybe more appropriate here. And another thing that I'm also mentioning in the slide is it's a cold start then starts affecting your data calls. Data calls generally don't matter when was the last previous call, but in Velo does. Like, if you haven't run any code for a while, you may not have a running code container, right? Your code is off. So the first request to the Velo backend, whether it's from hook or to web method, it's a subject to container call start. So you may notice that some queries are slow, then they are faster, then your container is shut down for being called in 5 minutes. Then again, next call is going to be slower. It applies with methods as well, but if you can avoid both, then you're not subject to call starts. Again, Velo is working to make call starts really small. I think we're still industry leading, but it's still more than zero. Also, another simple trick, because your containers run for extended time, you can actually fetch and cache data in your container. So if you have a web method, you can just take a global variable, put the result there, and then if it already exists, just return it. It's especially useful if you're doing multiple calls and you're doing some post-processing and you're combining. So it's kind of a caching that you can implement yourself and cache all kinds of computations and external calls and any other effects. So you're in control, and it's a simple trick. It lives for however container runs, which is usually around 5 minutes. And on a higher traffic sites, it can be quite a significant improvement. Yeah, as I've already mentioned, dynamic pages are cached. So when using data binding or fetching data, prefer using dynamic pages because they have some trick up their sleeves. Data sets in generally also have some tricks. So for example, if you have many data sets on the page, there's going to be some aggregation happening, trying to fetch all of the data and package it inside of Wix data centers and just fetch all the dependent data and all the multiple Wix data sets sort of with one go. So it's going to be faster than running your code. It's as if you had multiple Wix data queries in the front end, and you decided that I'm going to write a Velo web method in Velo, do all those computations in backend, and then return a single result. So when you're using data sets on the page, that's sort of what happens. We can have the smart server, which figures out what data is needed, how data sets are dependent, and tries to return it in one go, which is also a bit faster. So whenever you're using data binding, you can expect that there's some optimizations that we do for you that would not be done when running like a simple Wix data query, or you would have to do some tricks on your own. Cool. So this is for my easy. So one thing is that another new feature is that there's Wix Data is dynamic. Like every data center has multiple databases, and if we can go back to this picture, like every main data center, we're going to run multiple replicated databases with your data. So there's always one data center, depending on your sites. It may be different database for different sites. That's the primary. So the primary accepts the rights. So if it's a primary data center that hosts the primary Wix Data database, all of the rights, all of the inserts and updates are going to be routed to that database. So even if you're in some other location, it's going to go through micropop, it's going to main data center. And if it's a write operation, it figures out that there's no primary in this data center, it's going to forward that call to another data center. That primary database is going to accept the write, and then it's going to replicate the data to all of the other data centers, to the instances that we call secondaries. Now, because of this effect, once you write some item and then do a subsequent read, so you go for this. Now that subsequent read is always going to go to the database that's closest to you, to the main data center that's closest to you, and the database that's most available. Now that database may not have the data that you have just written. It may not have the update that you have just issued, or may not have the inserted item that you have issued. And what you can sometimes notice that while you have just inserted something, if you try to get it or try to issue a query that's matching that item that you just there, you may not find it. So if you have this flow where I'm doing something on the page, submitting a form, going to another page that should display the data, it may not be there yet. It hasn't replicated. So we've added this option for a consistent read. So what it does, it will force reading from that primary database. Now that makes this read a lot slower, because it will always go to that some location, which may not be the most proximate location to your client. It will make sure that it reads from the primary, and it will always return the item that you've inserted. If this operation succeeded, if it didn't throw an error, if the promise has resolved successfully, this will always read that item, well, provided nothing deleted it. But it comes at the cost. This is almost always slower, probably almost, and this way may fail at a higher rate than otherwise the operations would. So use this sparingly, but in cases where you do need this read after write, where you do know that you're reading the item that you may have just written or updated, you can use this option to just make sure that the item is there. And another thing is solving data consistency issue. Is the question that I had many times is, what if I have a bookings reservation system, or what if I want to avoid two users overwriting each other's data? How do I make sure that the changes happen in sequence, or one user cannot overwrite changes of the other user? And sort of there's two answers to this: optimistic and pessimistic locking. We don't yet have optimistic locking in Wix Data, but there is a way to insert pessimistic lock. So what the trick that you can do, let's say you have this resource. Let's say you have a collection of rooms that you allow to reserve. So this is a weekend, the resource is a room for a weekend, and you want to make sure that no two users book it. So when someone goes to view the room, for example, you can say, I'm going to lock the room because someone is planning to reserve it, or maybe someone has reserved it and is now about to pay for it, and you don't know if you're going to revert or not, or maybe someone's just looking at it. You may insert a lock. Let's say this is the identification of that room. So if the database of rooms has, if you're locking a single item, this would probably just be the same idea of the resource that you want to prevent someone else from editing. So whenever someone edits that resource, you can lock it. You make sure that you acquire this lock so that the insert succeeds. If it succeeds, that means that lock didn't exist in the database, right? So that means you have acquired, now you're the owner of the resource. If someone else tries to acquire this lock to edit that resource, to book that room or to book something, you would fail. We would fail with 0074. That means that item already exists. That means that lock is already taken, that resource is already locked. Now this is consistent. This operation runs against the primary segment, so it always works. And now you can go read that resource. Once you read it, you know that no one's going to be updated because your code before update will always require this insert. You can read it, you can show it to the user. User can book that room in our room example or do any other modifications in whatever this resource is. And once it's done, you remove the lock. You can say, okay, I'm going to remove the lock. And thus freeing up the resource. Now someone else can go in. So you would lock, you would read it, you would do any modifications user wants or user, and then after it's done, you would unlock it. Now there's a chance that these locks leave. So let's say user comes into edit resource page, logs the resource, closes the browser tab, the lock stays in. So it's a good idea to have a lock cleanup job, like have a timeout, lock is invalid after some time, and just do maybe run like a velo task to remove all the expired locks so the resources don't accidentally get locked indefinitely. So that's my trick for consistent updates. And it's also very useful when you're trying to update multiple items all together so that they're all consistent. Again, issuing a lock, doing the update on multiple resources, unlocking, and then allowing someone else to do the update on those resources. So there, hope this is useful. This is it for my sort of getting into the Wix Data Flow presentation. And now we can cover your questions, everything you wanted to know about Wix Data, but didn't yet have a chance to ask. Okay, so question one, how can we make queries faster? So I think I've answered some tips. So the biggest thing is usually to model your data correctly. There's usually trade-offs, whether I use multi-references, whether I put everything into the single item. So for example, if you have a complicated data model where you have lots of relationships, let's say you're loading articles, those articles have multi-references with the comments and maybe also have references to another collection and whatnot. The question is, how do I model it? Because you have two ways. One is doing this normalized model where everything is referenced and everything's correct. The other model is putting everything together. Wix Data is document database. You can store any JSON in the database. If you see in the content manager, you can create JSON columns, you can create array columns. And generally, if you need everything, loading one big item that has everything embedded, that has array of comments and all the other related resources, author information, and everything that you would store in different collections all together in a single collection is going to be faster than doing includes and fetching all the references. Now that's only faster in the case where you need all of the data. If your most common use cases where you need those specific pieces of data separately and only occasionally you need everything, then probably you're better off modeling everything with multi-references and splitting everything all together so everything's queryable granularly. If your main use case is showing lots of data together, then you may be better off putting everything in one big item. So you just do one query, do one fetch, just go there to database, fetch the whole thing, and just show it. You know, your article, your images, your comments, and whatever else associated, author information. So it's really thinking about these things. It's hard to answer this generally because it depends on the case. Do you read everything more often? Do you read everything granularly? That's the answer. Sometimes you can use hooks and have both cases, you know, have this nice model that's all built for references, use that to users, but also have hooks, build that collection where everything's already aggregated and pre-joined and pre-included, just so in that specific case, when you need it, you can query that collection. But again, it depends on the case, and you have to think about these things. How can we create a good database design to make it scalable, flex, and easy to manage? Yeah, so sometimes performance and easy to manage don't go well together, and you have to make trade-offs. Sadly, no silver bullet. I don't have one. But again, what I can suggest, think about, you know, sometimes maybe technically behind the scenes to make things faster, you can build like these materialized views and use hooks and use maybe velo tasks to kind of rebuild the data that you serve from your code and or data binding into the page, and have different set of tables that you give to your users and say, hey, this is what you added. And you can put them on the top level, say these are editable, user editable collections, and your technical ones can now be put in a folder. Another great feature in Content Manager, so you can create a folder, do not touch technical things, and put those performance optimizing collections there. Okay, when we should use Wix collections and when we should use external collections. So one easy answer to you, external databases kind of originally came in sort of for external data sources. So if there's already an API or another database that already exists, and it maybe has multiple customers, you are happy with database, you have other tooling on it, use external database by all means. There may be, whenever you're using external database, you have to keep in mind that there is performance impact based on where the database is. If it's far away from our data centers, there's extra round trip when you're calling Wix Data, then going to that database to fetch the data. Another use case is you need some specific features that Wix Data doesn't have. So one example that comes to mind, for example, geospatial indexes. You are storing lots of locations. You have a Google map where you load 10,000 different locations, and you're making a site for McDonald's. You need to show every McDonald's, and you want users to be able to quickly find McDonald's near them or McDonald's in a certain area. And so database that has geospatial indexes is going to be much more efficient finding things around certain point or within certain area than any other database that doesn't have it. So if you have that sort of a case like it, where some databases just excels at what you need, then it's another great use case for external database and saying like using that instead of anything else. So again, it's either some specific need you have, either some specific load patterns, or some existing resource that already exists and you just want to connect it. It's perfect use case for external databases. But also may come with downsides for performance or some things not working. For example, if you have external collection today, we don't yet have a way to know that the data has changed. So if some call got cached, we will not know that you have updated an item on that external database, so the cache will not get invalidated. Eventually, we're going to solve this. There's going to be a way to sort of send event back to Wix and saying, okay, this has changed. Please do whatever you do. So it affects, Wix search indexing pages based on those items, caching things on those items. But today it doesn't exist. So again, something to keep in mind. If you're using external database, you may want to not force the cache. Cool. If you have questions about using that in any specific situation, feel free to ask them in the help channel. I'm usually there, and I'll try to answer it. Good. Another question: how can we use Wix Data API's feature in a creative way? Example of sending. I think I've shown a few, maybe like using logs in the presentation. Hard to think about something, but there's usually creative solutions to any problem. So if you have a problem, shoot a question. If I'm on the help channel, I'll maybe share some creative solution if I have one. Yeah, general tips and tricks, share that. Cool. Questions from Kenton. Is there a limit applied to data query when working with the functional request? I wonder what functional means. It probably means like velo function. All the limits on data are the same. Like data API just has data API limits, like your 5-second duration, your, as I mentioned, 100 megabytes for sorting. Everything applies equally the same, whether you call it from front end, whether you call it from back end. It's just calling from backend is a bit faster in general because your velo code runs somewhere close to where the database is, and your client codes runs where the client is. But otherwise, the limits are the same. When delivering new queries, I sometimes send into timeout error 128, and the phone queries even basic one returns 128 for 5 minutes. Is it related to database? database tokens, I know what you're referring to, which, yeah, I think Kenton was a Velo master. It's a very old thing that no longer exists. So it's for those who haven't been with Velo 5 years ago, we had this interesting situation where if you made a web method or HTTP function call, and if you extend it past the 14 seconds between it when it returns the result and you continue it working, you know, container is live. It will, your code, even if you don't return anything, will run for as long as the container is alive. So if you run an infinite loop that doesn't ever return a value from that method, your code is going to continue running, even though on the client got a timeout. And it used to be that on those calls, we had this data token that allows you to access Wix Data, and that token would sometimes expire faster than the container dies. And so your last few queries on that long running job would just fail, or you're not authorized. So that's no longer the case. Now the authorization was fixed quite a long time ago. And that no longer happens. Like your calls are always authorized for no longer for how long the container runs. I think we're going to have option for like longer running containers, 10 minutes maybe instead of 5. And that's going to continue running. Like this is no longer an issue, and there's probably some other issue in this case. One thing that can happen where you get an obscure error, but that happens with all Wix APIs. If you're doing like load testing and everything stops working, we may have thought that this is a DDoS attack, and our automated protection kicked in and blocked you. This can happen. Then you're going to get weird errors that's nothing like it, because we're blocking you from accessing certain Wix API endpoints or big part of Wix altogether. But what happens in this case, I don't know. Error 128 is probably not Wix Data error, because 128 is in Wix Data, I think, related to external databases actually, or DB drivers. I don't think that's what in this case. So Kenton, feel free to write me. I'll look up what's happening for you. Is there some caching mechanism at Wix Data level? If 2 users list the last 50 items of a collection, does the second user benefit from any boost? From any boost, yes, but generally I would say no. So there's no deliberate Wix Data caching right now, aside from using data binding. Like if you're using data sets and dynamic pages, yes, there's caching there. It's going to run faster. Everything I talked about caching applies there. When you're using just Wix Data queries, there's no caching. But if you're going to test it, and if you're going to run the same query all over again, you may see that it's getting faster. And the reason for it is simple, because in every database, or most, it's very hard to avoid it, there is some caching. Like typically your data sits on the hard drive, like it's on your disk. The same as in our case, your data is sitting on the disk. But if data is more commonly asked, read, so whenever your operating system reads something from a disk, for a while it stays in memory. It stays in your RAM. RAM is very fast, the disk is not as fast. You know, it's like 100 times difference between the two. So the same with queries. If you run the same query again and again, you will pre-warm that data in all the data replicas close to you, and may see that data starts to return faster. You shouldn't rely on this effect, like you don't have any control, and the way the decision is made to cache something and for how long to keep is not really something you can or even us could control. It's really just operating system running the instance of database. But you can notice that effect, that it can get faster if it's loaded multiple times. And last question is, what about dataset? Do datasets provide any caching mechanism? Datasets do, especially dynamic dataset does. Static datasets don't yet, but they do also employ some performance optimization tricks that data binding that can and often does work slightly faster than running your own data query. Okay, so these are all questions from Discord. Sorry, maybe a dumb question. There is no dumb questions, only dumb answers. So No, hooks use the API, correct? Could you just directly inject, push and pull from the database itself instead of writing hooks to use the API? Do you have to use the hooks, or you can just use, your code around it without not necessarily writing in the hooks, but just in your code? Yeah, you don't have to write hooks. Hooks just make sure that wherever the call originates from, so whether it's an external call, whether it's content manager doing Wix Data calls, whether it's your side data binding, whoever calls database, hooks are for those operations that are covered by hooks, like writes, for example, are guaranteed to run. Like they are going to run whoever calls it. But whenever it's your code running the hook, you don't have to put the logic in the hook. You can put the logic in web method, call web method from, let's say, front end and wherever. Do some logic before hook, do the data query, transform the result, and only then return it to the front end for rendering. You can absolutely do that, and it's often the better way. So I hope I understood your question correctly.
Steve just chatted and he said that answers it. Thank you very much.
Awesome. Good. Do we have any more questions?
No questions, just very well. Glad to hear from you again, Giedrius, as well as I'm excited about some of these increases. Like I know that they're increasing the timeout from 14 seconds to 59 seconds for some backend functions on the new plans. And then moving from 5 minutes to a 10-minute container is big. It's big because we can do some bigger stuff.
Yeah, so there's going to be more options to grow. This sort of an ongoing change where we're giving more. It's very large sites. I think we have already received offers to upgrade, and it's going to roll out for everyone. Like this more tiered Wix Data, which is, I think, going to move us to much better quality of service and more capability for those who need it.
Love that. So I guess I do have a question then.
Sure.
For the maximum number of HTTP function requests per minute, is there any plan to, and that's not collections, but is there any plan to increase from 7,000?
Yeah, so there's also, I don't remember the numbers now. I don't have them in hand, but they're also going to be tiered in that they're going to be tied to the plan. So the sort of personal plans we're going to have less, and the business plans are going to go up and have more. The same will extend to the containers. So for example, now I think all plans have, like, you can have one container. If you're hit so hard that container cannot handle requests, that's game over. What's going to happen is also going to become tiered. So the current container size and sort of limited one is going to be left on that, simplest plan. And then as you go up, you're going to get a bigger container. So for example, more memory and more CPU capacity, and also more containers. So your backend code will become scalable in that if one container can handle and you have like a burst of requests, it's just going to be able to scale to more. So you're going to be generally able to do more and faster with higher plans.
Gotcha. So if I understand correctly, we're going to have the chance to have more requests per minute per container. But if the site gets so much traffic, we might get multiple containers with that higher amount. So it shouldn't go down.
Yeah, it's going to be able to handle more.
That's pretty exciting. Yeah, man, this is good news.
Awesome.